Hello guys, welcome to my new video. Today we are going to talk about triangles and its properties. It is going to be quite an interesting chapter for sure, uh, because there are many very important interesting properties of triangle. But before moving into triangles, let's see what we did learn in the last chapter. And some of those concepts we are also going to use in this one. So if you remember, we were talking about lines and angles in the first video of lines and angles. We spoke about angles. In the second video we talked about lines, in which we learned intersecting lines, parallel lines, transversal lines. So transversal line basically is that line that intersects two or more lines in different places, yeah. And then obviously when it strikes or intersects different lines in different places, angles are formed, and we understood what those angles are called. And if there is a transversal intersecting parallel lines, then what is the relationship between those angles? So in order to learn them again, if you haven't seen those videos, please go back and watch it. It's on the channel itself. And today we will learn about triangles, something which is I particularly enjoyed a lot as a student. Triangles and circles were something I really enjoyed. And between these two chapters there's some very interesting concepts, and very easy. That I can promise you that it is very easy. And so it is the starting of learning triangles. As we go deeper, as I continue to make more and more videos, you will see that it will become more complex as we move ahead. And but nothing to worry, these are starting concepts. And then later as we progress, we will get into correlations between angles and length of the sides, etc. But right now we are just going to study angular relationships and stuff. Easy stuff, but very interesting is what I can tell you. So let's move into the first one, and this we have done in class 6th also, but let's do it again. Basis angle, there are three types of triangles. One is called the right angle triangle. What is a right angle triangle? In which one angle is 90 degree, right? Now if this is the 90 degree, this side is called base, this is called uh, perpendicular, and this is called hypotenuse. Okay. Then we have obtuse angle triangle. This is an obtuse angle triangle. It has got one obtuse angle, right? And then we have an acute angle triangle, in which all the three angles are acute angle, right? So that is the angle uh, types of triangle basis angles. Now let's see basis the length of sides. Three type of triangles. One is scalene triangle. We call it scalene triangle, where L1 is not equal to L2 is not equal to L3. All three sides are of different length. Then number 2 triangle is isosceles triangle, in which two sides are equal. And then the third type of triangle is equilateral triangle, and all the three sides are equal. All the three angles are equal in isosceles. These two angles, if these are the two opposite sides which are equal, then opposite angles will be equal. This is called the base. Okay. Oh, so that's that. And if you wish to look at it in detail, please go to the in on my channel, go to class 6 series and find out where I have discussed, I think, geometrical shapes, in which I have discussed triangles and all these three classifications, rather six classifications in detail. Now let's get into median and altitude. Once again, fairly simple concepts. So first we will start off with median. Now here I have taken a triangle ABC. Okay, I have taken a triangle ABC, and point D is the midpoint, right? Point D is the midpoint of side BC, okay. And then this midpoint I have attached, or I have connected with the opposite vertex, right? So I've connected it with the opposite vertex, AD. So AD is a median because it connects the opposite vertex to the midpoint of the side, and therefore I can say that BD is equal to DC because it is the midpoint, so these two lengths will be equal. Similarly, there can be a midpoint here, right? Let's call it E. And if I connect it with BE, okay, it will be another median. And if I, let's say this has a midpoint F, and if I connect it with opposite vertex C, then CF is another median. So a triangle will have three medians. And one important thing is that try and draw all the, draw any triangle and then draw all the three medians. You will see that basically all the three medians will intersect at one single point, okay, which is also known as centroid of the triangle, okay, which is also known as centroid of the triangle. And it is very, very critical. I don't think that in class 7th you're supposed to learn about centroid, but since I am talking about medians, I thought that I will call it out. What is important to understand and know is that the three medians are concurrent. Concurrent means they all will intersect at a common point. So that is medians. Simple. Now let's talk about altitude. Now this is triangle ABC. Once again you can see I have taken triangle ABC. Now let's say this first dotted line, let's call it AF. The second dotted line AE. The third dotted line AD. Okay. Now as I am moving from F to D, I see that the length of these sides is getting short, and there will be a point on which this angle will be equal to 90 degree, which is point L, which means that I have drawn a perpendicular from vertex A on the side BC, right? And it intersects the side BC at L. So the only criteria is that angle ALC, that should be equal to 90 degree, or angle ALB, that should be equal to 90 degree. So AL is an altitude. Similarly, I can draw an altitude from here, from point vertex B to side AC, right? And then again I can do the same from vertex C to AB. Like, assume that it is 90 degree, and basically, because it is a rough drawing, when you draw it properly, and I will request you to do so, you again will find that, or this is all the three altitudes, basically they will also intersect at a common point, and that point is known as orthocenter. Before I move ahead, there is one more point I wanted to say. Whenever we are drawing a median, because the median connects the opposite vertex to the midpoint of the opposite side, so the centroid will always be inside the triangle, or even the median, all the three medians will always be inside the triangle. Whereas in altitude, if there is an obtuse angle triangle, let's say like this, this is A, B, C. Now from this point, this is the obtuse angle. So from point A, if I have to draw a perpendicular on BC, it will be drawn like this. It will be outside the triangle. So in case of an altitude, not in all the cases will you find that the altitude basically is inside the triangle. In fact, you will have to extend BC to make sure that the altitude actually intersects. And in that case, in cases of obtuse angle triangles, you will see that the altitude can also lie outside the triangle. But in the same triangle, if you draw an altitude from C to AB, you will see that it is inside the triangle. Okay. If you draw from B to AC side, it may or may not be, depends basically. But in obtuse angle triangles, you will see that one of the altitudes definitely has to lie outside the triangle. So I thought that it's important, and I will ask you to also draw different triangles and see that what happens. It will just help you clear your concepts. Now let's come and talk about exterior angle and their properties. So first of all, let's understand what is an exterior angle. So let me first tell you, let's draw a triangle. Let's see, this is a triangle. Okay, the triangle is ABC. This is angle A, this is angle B, this is angle C. Now this angle that you see, if I extend BC, this angle and the angle basically on the outside, okay, of any, so this is, let's call it angle 1. This is an exterior angle. Similarly, if I extend this line AB, then this is an exterior angle. If I extend this line AC in this direction, then this is an exterior angle. If I extend this line in this direction, then this is an exterior angle. Okay, so that's how we define exterior angle of a triangle. Okay. So the exterior angle of a triangle has a property, and I will tell you what that property is. And for that I will first draw a triangle A, B, C. Now if this is angle 1, which is the exterior angle, the property says that the exterior angle is equal to the sum of opposite interior angles. So these three are the interior angles, but this is not the opposite, this is adjacent interior angle. These two angles are the opposite interior angles. So the property says that angle 1 is equal to angle A plus angle B. That is the property. But because this is math, geometry rather, and therefore it must have a reason, right? So let's try and prove it. You can remember also, but let's try and prove it. In the last one we studied parallel lines, so we will take that concept. Now in this figure that you can see, I have triangle ABC, and this is the angle. Okay, this is the exterior angle, right? Angle ACD is the exterior angle. Angle ACD is the exterior angle, and I have to prove that angle ACD is equal to angle 1, plus angle 2, right? That is what we just discussed. So let's prove it. What I will do is that through C I will draw a line EC, which is parallel to line AB. Okay, and when I do that, basically AC is a transversal in that case because it is intersecting parallel lines AB. Okay, let's extend AB a bit so that it will give you some idea. Okay, and similarly let's extend EC a bit. So I have to draw this in such a way that these two are parallel lines. Now when AC is the transversal, and this is these two are parallel lines, so then angle X, right, which is, and angle 1, these are alternate interior angles, right? These are alternate interior angles. So angle X is equal to angle 1. Similarly, angle 2 and angle Y, they are corresponding angles, right? Remember that AB and EC is the parallel line. Okay, therefore angle 2 and angle Y, right, they will be corresponding angles. Therefore angle Y is equal to angle 2. Let us replace in this equation. Angle ACD is equal to angle X plus angle Y. So what did you get? That angle ACD, which is basically the exterior angle, is equal to the sum of opposite interior angles. So we have proven it, and that's how you know that one concept leads to another, and therefore it is important to learn the concepts, understand the concepts, which is why in the previous video when I was covering transversal and parallel lines and the angles, I told you that it is very important to learn this concept because this is one of those concepts which we will continue to use. One small example here. So this angle is given as 110 degrees, and we have to find out angle X, and we know that angle this plus this angle has to be equal to this one. and this is given as 50, so x will be nothing but 60 degree, because then we will subtract 50 from 110. Simple question, but just wanted to put an illustration so that you understand. Now what we will get into is the angle sum property, and I have already discussed it in the class 6th introduction. Sum of the three interior angles of a triangle is equal to 180 degree. How? Once again, like I said, we will prove it. It is not that I will tell you and you will believe. Okay. So what we have done is that I have taken a triangle ABC, and it is the same triangle ABC. Okay. And this is also the same triangle ABC. Now you must be wondering that why have I taken the same triangle thrice, and I will tell you why. See, these are visualizations. Matlab, using pictures we will visualize certain things to learn why this angle sum property says that the three internal angles of a triangle is 180 degree. Now this is angle 1. What we will do is that we will pivot the triangle. Pivot means rotate. We will rotate the triangle in such a way that ABC is rotated like this. Okay, so this angle 1 will come here. This triangle I have kept as it is. This is same to same. This I have completely rotated by 180 degrees in such a way that angle 1 comes like this. Okay, and it is adjacent. Okay. So this side basically I have uh, this will be angle 3, and this will be, here is angle 3 and here is angle 2. Okay, that ways. So we rotate it in that manner, and then this side, basically side AC, this is A, this is C, and this is B. So this is AC, and this is A, this is C, this is B. Okay, so AC we will let AC coincide with CA here. Okay, and the triangle will come like this, and this is the same piece. Okay, ABC. Okay, but what we will do is that this angle 2 that you see here, we will bring the angle 2 to coincide here like this. Okay, so these two triangles I have taken same in the same manner. So, and once you rearrange the triangles like this, you will see that basically it is forming a straight line. So angle 1 plus angle 2 plus angle 3, which basically is the three internal angles here, you will see that this is forming a straight line around a point, which is this point, right? And we know that around a point, if there is a straight line, what is the angle? It is 180 degree. So it is a very good way to visualize, like through pictures you can visualize that this is this. Okay, and because I make these videos for some of the little kids, and for them it's important to visualize using pictures and diagrams, and even for adults I think not a lot of people visualize the three angles of a triangle in this way. And then there is another way, and this I will suggest that you do using a piece of paper. Take a triangle ABC like this, and then fold the triangle in such a way that you are able to create a altitude, okay, on the side BC. Okay, so this is the altitude. Now I have just expanded the same thing, थोड़ा सा बड़ा करके magnified it. Now you see that ये जो आपका vertex B, okay, this vertex B, what I have done is that I fold the paper in such a way that this B basically comes and coincides with M. Okay, so I will fold the paper around some line here, which basically will be the midpoint of this part only. Okay, and I will fold it from here in such a way that this angle B basically comes when I fold. So now there is no paper here. Okay, it is folded, and now this has come, and so this is B, right? This angle B has been folded here. Similarly, for this small part I will fold C in such a way that the vertex C will come and coincide with M. So once again, I will have to fold it like from somewhere here like this. So forget that, because it is paper, so you will be able to fold it. But then when you fold, this will come and this will be angle C, right? And similarly, I will fold A in such a manner that A will also come and coincide here. So once again what I have done is that I have brought all the three angles, and you will see that all the three angles are here around a point forming a straight line, which tells me around a point forming a straight line, which tells me that this is 180 degree, right? So angle B, this is angle C, and this is angle this is angle A, okay, which I have folded the paper like from top to bottom, okay, from top to bottom like this I have folded from here to here, like from right to left. So this angle B plus angle A plus angle C is 180 degree. So you can do that using a piece of paper. It will be very interesting. But these are just illustrations and we will also prove it. So abhi we learned, what did we learn? In a triangle we learned and we proved it, that if it is triangle ABC, okay, and this is D, then angle ACD, okay, which is this, which is the exterior angle, is equal to sum of opposite interior angles, which is angle A plus angle B, right? And this is angle C. Now angle C plus angle ACB, angle ACB plus angle ACD, and see how easy it is. ACB plus ACD, basically it is a straight line, linear pair, right? It will be 180 degree. But I know that angle ACD and angle ACB I can write as angle C, and ACD is nothing but angle A plus angle B. We have proven it already, angle A plus angle B. So what do we get? Now it is a proper mathematical proof that angle, three internal angles of a triangle is equal to 180 degree. Simple. Simple as that. So while we know that okay, three angles of a triangle equal to 180, we should also know that why, how. So we have learnt in three ways, okay, in first in this way, then second by folding the paper method, and then third by the proper mathematical way, in which we utilized, what did we utilize? We utilized our learning that the external angle is equal to the sum of opposite interior angles. इसको prove करने के लिए what did we utilize? We utilized that the alternate interior angles and corresponding angles of a transversal when it intersects two parallel lines are equal, right? So we used that concept to prove this, and now we are using this to prove that three angles of a triangle are equal to 180 degrees. So see the correlation. It's beautiful. Sum of the lengths of two sides. Okay, so in a triangle, what's ABC? We have three sides, AB, BC and AC, right? Now guys, sum of any two sides will always be greater than the third side, always be. So AB plus BC will be greater than AC. Similarly, BC plus CA will be greater than AB, and similarly CA plus AB will be greater than BC for all triangles, and you can just visualize it and see, right? So a classic question will be given to you is that, can you make a triangle which has sides 9, 2 and 4? The answer is no, because 4 plus 2 is 6, which is less than 9, and it will never ever happen in a triangle. Why? And just think, like if you're drawing a triangle, let's say first I draw a line segment of 9 centimeter. Okay, I have drawn it. I have in my compass 9, 2 and 4 I had kept, right? So in my compass, using my pencil, I have cut an arc of 9 centimeters. Now when I fix my compass here and cut an arc of 2 centimeter, 1, 2, okay, so it will bisect here, and okay, then it will go in this direction, and then from this end, if I have to cut an arc of 4 centimeter, 1 2 3 4, so 4, this is 2 from this side, right, and this is 4 from this side. Still I have 3 units of distance to cover, right? So till the time 4 plus, or this arc and this arc will not be more than 9, I will not be able to have an intersection above the line. If I don't have an intersection above the line, I don't have a triangle. So that is how the sum of two sides is always has to be greater than the third side if it has to be a triangle. So the question which will be asked is that in this fashion they will give you three sides and say that can you tell us if it is possible to draw a triangle. So simple, if it is a side like this 9 to 4, so you simply have to check 9 plus 2 greater than 4, yes, but you have to check for all combinations. Then you have to check 9 plus 4 greater than 2, yes. Then you have to check 2 plus 4 greater than 9, no. Therefore even if one, for one pair the condition is not fulfilled, the triangle cannot be drawn. So that was it. I hope you enjoyed the video, and thank you so very much for watching it. Write to me if you have a feedback. Drop a comment if you have a question. We'll be more than happy to come in and answer. See you in the next one. Thank you very much. Bye.